Alright, this section is multiplying polynomials 3.5. And with 3.5, when we are actually doing this, we're also using our product rule for our exponents. So you'll actually see the product rule used a lot in this section. And then after a while, you're going to get so used to it, you're not even going to think about product rule. You're just going to do the steps. So remember when you're multiplying a binomial and a polynomial, or multiplying a monomial to a monomial, you're multiplying the numbers out in front. So 8 times negative 11 gives me a negative 88. I had different signs, and my answer is going to be negative. So I have 8 times negative 11, which I multiplied. And then for the variables, we're going to do that product rule. We have the same sign, so we're going to keep the base and add the exponent. So 7 plus 5 is 12. So negative 88x to the 12th is in simplest form. Now, number 2 is different because we've never had a variable on the outside when we did our distributive property. So this is where our product rule comes in handy when we're actually multiplying polynomials. So when I distribute the 4 to the first term, or 4x, the 4 is going to be multiplied to the numbers, and for the variables, you're going to do the product rule. So I have 4 times 1 is 4. X times x squared gives me x to the third because 1 plus 2 is 3. Alright, so multiply the numbers, add the exponents for the same variable. So 4 times 4 is 16. For the variables, x times x is going to give me x squared because 1 plus 1 is 2. And then the last one, I have 4x times 3, so 4 times 3 is 12. And there's no other variable, so the x just comes over. Now when you're using this distributive property, you're not going to have a lot of like terms, so once you distribute, you're basically done. The next example has 2 variables on the outside, so make sure that you're always matching your x's with your x's, your y's with your y's, or other variables like that. So you don't want to mix the exponents for the y's with the x's. It won't go together. So for our first distributive property, I'm going to have 4 times 7, which is 28. And for my x's, I have x times x to the third, which is going to be x to the fourth. And there's no other y in that first term, so the y squared just comes over. So since I matched the 4 with the 7, I got 28. The x times the x cubed, and I got x to the fourth, and there was no y, that y squared come over. Alright, for the next term, I have 4 to the 3, that's going to give me 12. So 4 times 3 is 12. For the x's, I have x times x squared, that gives me x cubed. And then for the y's, I have y squared times y squared, that gives me y to the fourth. Alright, the next term, I'm going to have 4xy squared times negative 9y cubed. So 4 times negative 9 gives me negative 36. There's no x on this second or this third term, so I'm not going to have anything to add to that x, so the x just comes over. And y squared times y cubed gives me y to the fifth. So just multiply the numbers to the numbers, add the exponents on the same base, and that's going to give you your product rule. Now, when we use our multiplying binomials, it's the same idea, except we have a binomial times a binomial. There's not going to just be one term on the outside, it's going to be multiple terms. And we usually use the word FOIL for this particular section, and that means you're multiplying the first to the first, the outer two, the inner two, and the last to the last. So what I like to do as an instructor is to not basically teach the FOIL part of it, but teach the distributive property with binomials. So don't even look at that 5. I'm going to distribute that 4x to the 3x. So I have the 4 times the 3 is 12. The x times the x is x squared. I'm going to distribute the 4x to the negative 4. So 4 times negative 4 is negative 16, and that x just comes over. Now that I've distributed that 4x to everything, I'm going to now distribute the 5, the next thing in that first polynomial. So I'm going to distribute the 5 to the 3x, and 5 times 3x is going to give me 15 x, because 5 times 3 is 15, and that x just comes over. Now I want to distribute that 5 to the negative 4, and 5 times negative 4 is negative 20. Okay, so let's just recap what we just did. I distributed that 4x to everything in that second polynomial, so 4x to 3x was 12x squared. 4x to negative 4 was negative 16x. Then I distributed the 5. 5 to the 3x is 15x. 5 to the negative 4 is the negative 20. Now when you do the full method, most of the time you will always have like terms. So always look for like terms, and our middle terms are usually what's the like terms. So in our middle terms, they are like, they are both x to the first, so that means that 12x squared just comes down to my answer, and I have a negative 16 and a positive 15 different signs, so I'm going to subtract at the sign of the bigger number is negative, so my answer is going to be a negative 1, because 16 minus 15 is 1x, and then bring down that minus 20. And this is in simplest form. So this, I'm going to pick up on the next ones in the next video, but this is basically what we're going to be doing for the rest of this section. The full method, or distributing a binomial to a binomial.